one interval. I see the graph from left to right is rising. Now it looks like, if I'm looking at it correctly myself, it looks like it falls next. But then I see it rise again. Now can you tell me in interval notation, where's the next spot where it rises again? 0 to 4. So we put union 0 to 4. And that's where my graph is increasing. Yes?
Do we not use brackets because?
Beautiful. Now, if you say bracket, guess what happened at bracket? I don't like brackets on this one. At brackets, it's doing nothing. The graph is doing nothing. It's not going to rise, it takes off. Okay, if you put a bracket, I don't think that's kind of wrong. Now, number 2, on what intervals is the function falling? The guy said always go from left to right. Tell me in interval notation, when is it falling? Anyone? Thank you. That's one piece done quickly. Is it falling somewhere else?
4 to infinity.
Tell me again?
4 to infinity.
4 through infinity. 4 and then forever. It's falling. Is that making sense just the way we're talking about it? Without showing much more detail. Now, listen very, very carefully. This is some vocabulary. Number 3 says, name the local maxima. Plural form for maximum. So there could be more than one. So guys, look at that graph from left to right and tell me, do we see points that I might want to identify as maximum?
4 and 2.
I see -5, 4, and the 4 is really what I'm looking for, that y coordinate. And there's another one, what, at 4, 2, and the y coordinate is what, 2? So if you list the entire point for me, I'm not gonna count it wrong, but usually they just want the y coordinate. So it's -5, 4, and also it's 4, 2. Actually, we're just looking at, and I'll do it like that. We're just looking at those two numbers there. Those are called local maximum points. Now, before I move on to the next one, if I go back and look at either one of those, I'm gonna look at -5, 4. Is that point sure enough higher than all points nearby it? In other words, in its locality. Is it the highest point? That's why they call it local. Okay, now for the local minimum, and they want only the y coordinates, guys. The local minimum, if I look at it correctly, guys, don't let me mess up here. Does anyone see a point that you might label as local minimum?
-3.
0, -3, and it is -3, thank you. They just want the y. There's the local minimum. Now, do I have a student who might think that maybe why not consider -7 too?
It's not local.
Tell me why maybe I should not, looks like it's over there, but maybe I should not consider also -7 too as a local min. Give me a little rationale, yes.
Is it because that's where it starts?
That's where it starts, and then something else. It is where it starts, something else. That may say, no, stay away from that, Mr. Professor. Yes.
It's the point next to it is a lot further down.
Okay, let me ask you this, and both of you guys are on the right track here. Is there any part of the graph to the left of -7, was it -7? Yeah, -7. Is there any graph to the left of -7 to begin with? So I don't have anything to compare it to. So when they ask for a local, you gotta have something to the left and to the right in that locality. I don't have any graph to the left of that, so I cannot consider it as a local. Cannot. Okay, now it says name the absolute max. This is vocabulary. Now when they ask you for the absolute, now they want the highest point of all points. What should I list as my absolute max, the highest of all? Is that 4? Yes. If you just put 4, I'm happy. If you want to list the entire point, -5, 4, I'm good. Why not list 4 too, also? For absolute.
It's not absolute.
It's not absolute. We're looking for just one point that's the highest of all. That's absolute. Now next it's asking for, if there is one, is there an absolute min? Is there a point on that graph that is lower than all points on the graph?
-3.
Oh boy, you would think, tell me again.
-3.
-3. Why can I not accept -3? We got you on that one. Why?
Because it goes like down to
Thank you, it drops down forever. It just keeps on dropping down, so there's none. So yeah, there is none here. But I see exactly why you said that. There is no absolute minimum on this one. Keeps dropping down forever. Now here we go, Jonathan. Number 6. On what interval or intervals is f of x greater than 0? You have the graph in front of you. That translates into, when is my graph above the x-axis? And tell me someone from left to right, an interval.
-7, -3.
Love it. -7 up to a -3 is one of them.
And then union,
Okay, hang on. -7 to a -3, and you're telling me it's above the x-axis somewhere else. Where?
2, 6.
Love it. Love it. Done. Now the next part says, on what intervals is it less than, and be careful, less than or equal to, that means below, or it could be right on the x-axis. Guys, from left to right, does anyone see anything where it's below and right on? It could be right on the x-axis and also below.
Close -3.
Oh, bracket, -3,
2, bracket,
2, hang on, bracket,
union,
union,
bracket 2,
and out here, bracket what?
2, or 6,
Hold on, this is below.
6,
Yep, 6.
infinity.
There you go. That's what I wanted to hear. That's where that graph is below, and also it could be on. That's why he asked me to use brackets there. Okay, I have one of these on the exam Monday. I'll have the graph drawn for you and just ask you about local max, local min, absolute max, absolute min, increasing, decreasing, so forth and so on. Next part. Beautiful. Guys, the domain on this graph. You say, Professor, you didn't name the function for me. Well, no, I have the graph though. Domain, the extent of the x's. From left to right, what extent does this graph cover? What's to the left, the furthest it goes out for the x is what? -7. Now how far out to the right does it go? Infinity. Just bracket -7 through infinity. Done. Range, that's the y value, that's the up and down. Guys, tell me based on your graph, how far down does this graph drop? Negative infinity, it drops down forever. Now, how high up does it go? 4 for the y's. So it's negative infinity up to 4, including 4, bracket. There's your range. And the last thing says zeros. Now, I think I have used the word zeros at times discussing. Zeros are the same as the x-intercepts. So guys, the x-intercepts here, and I'm going to just use a single number to identify them, are, help me out here. Is it -3? Yep. -3 is a so-called zero x-intercept. A 2, was it?
2.
And a -5, was it? Not -5, 5.
Just 6.
6.
Was it 6? Not 5, 6. That's wrong here. So -3, 2, and a 6 are the x-intercepts. And they call these zeros. How's that look? So if you have a graph on the test on Monday, which you will, and I ask you, don't do anything with it, just look at it and identify increasing, decreasing, local max, local min, absolute max. So we can do that.
Yes.
Okay. Guys, any concerns here? Wow, we really got what we've gotten done here. No wonder we're staying so busy. Now, flip it over. And a few minutes before we take a break, let me identify some of these for you. They call these parent functions. You've seen these before, like this, somewhere. I'm not gonna list all of them for you, but I am gonna list a few from that handout. And I'll take me right up to break, like right where I part, Anna. I think we have a good group here to work with. I think they're gonna do well in calculus. Okay. Okay, guys, if you look through there, I gave you quite a few there to look at, so-called parent functions. We know, and I should have brought my straight edge in here to grab these. One, for sure, if it looks like this, I'm just doing a rough sketch. Here's your grid, X and Y, and all of a sudden you plot points, you connect them, and you get a graph like this. You say, Professor, my goodness, that represents or a parabola that represents this function. So if I see an x squared, it's going to be a parabola for that graph. Now that's just the most basic one. It's called the parent function. Now can I transform that later on after the break? Yeah, let me say now graph x squared plus 2. Then we add a 2 to it. Or then we have x minus 2 quantity squared. To change it a little bit. That's what we call transformations. That's after the break. Also, I noticed just a few here. They have included this as a function, parent function, x, y, and they did this, if I can make it reasonable here. What might that be representing?
The absolute value.
Absolute value of x. So this is y is equal to, or f of x is equal to, absolute value x. Which I have not looked at with you guys yet, but that's a V-shaped graph. So if it's an absolute value, its shape will be that later on if I need to use it. Another one here, I think I have 4 of these in mind. Let's look at y is equal to x cubed. And some of us may know what x cubed without plotting points may look like, but the shape of an x cubed graph, it's there on the handout, I'm pretty sure. Yeah, you can plot points, but does it take a shape something like this? For x cubed. I think it's on the handout, isn't it? Okay. One more that we'll do. All those are right there for you. This one comes up quite often. Y is equal to square root x. We work with square root x in this class. But what does it look like graphed? Well, this is picture. If you plot points or accept that handout, the handout says it should take a shape something like that. For square root x. No, on that last one for square root x. Can anyone tell me about that? That's the graph. That's no problem. Can anyone tell me anything about that graph? Leo. And the domain, let's get this. He said, Professor, the domain from left to right is bracket 0 through infinity. I agree 100% of that. The domain on this one, since he mentioned domain, negative infinity through positive infinity, everything. This one for domain, negative infinity through positive infinity. No problem. Oh my goodness, this one's also negative infinity through positive infinity. This was the range right quick before we take a break here. The range on this one, guys, the up and down, how would you describe the range on the parabola?
Open, close bracket, 0
0.
to infinity.
Absolutely.
And the
Range on the absolute value graph,
it's the same.
same thing. Beautiful. This one,
All real numbers.
all real numbers. We'll write mine in interval notation, like that. This one,
Same as the domain.
that's what's gonna be bracket 0 through infinity. Okay? Now, before we take a break, on that last one. Can anyone tell me in your own words, when I say the domain is this for a square root, can you tell me in your own words, what are we talking about? You got square root x, that's my square root function. And we're saying for the domain, it's bracket 0 through infinity. What does that mean? In your own words. What does it mean? Go for it.
Any number plugged into the function as x can be anything equal to 0 or greater.
Okay, he's gonna be professor. This right here tells you that underneath here, you cannot replace any number underneath there unless it falls here. In other words, you cannot replace a negative number. You cannot do a square root on negative, go to imaginary numbers. That's what that means. Now tell me, what does the range mean?
Output of the function can never
The
be
output,
less than-
after you do the square root, you put a positive number underneath there, like 25. Square root 25 gives you a what? 5. The output coming out will also be positive if you see a square root symbol. Okay, so we got that out of the way, domain and range. Guys, I think we've done a good job so far. Yes, no? Okay. Yes,
Do the rest of those, shapes have a name?
beautiful. Here, I'm gonna just identify this as a parabola. This one is called the absolute value function on a particular name. They just identify this with the cubic function. They just give a name like that. Square root function here. They do not give a specific name to the graph itself. Okay? Right? Making sense? Now, we're gonna take a break, of course, but when you get back from the break, here's what we gotta do. We gotta take one of these parent functions, it could be one of those also that I did not list up here, on that handout. We gotta take one of these parent functions, like this one, and all of a sudden they say, now sketch this. Take that parent function, x squared, and now do that to it. Now I got just a couple minutes. I'm not going to graph. Does anyone think they know before I give you another handout that you don't have yet? That you might do, and you may recall doing this somewhere else. Can I take that parabola and do something to it? But do what? Yes, go for it. Jonathan.
You would, it would be a
Okay,
parabola.
let me do this first up before you can start. There is something that means to do.
So it would be not increasing, it would be a decreasing.
It's gonna be
parabola.
flipped over,
Over.
upside down. You'll see all this on the handout after the break. Does anyone recall before we get to it though, what might that mean to do?
That would be a decrease of 3.
Well, you said it right, but be careful.
You move it up about the y.
I knew you were gonna say that, not up.
Is it a shift?
It's a shift. So which up or down or right, left?
To the right?
To the right, 3 units.
Okay.
You will not know that until you get the handout. That's what it means. And finally, yes, this means to do that to my parent function. What does that plus 4 mean?
Up 4.
Vertically up 4. So you gotta start out with the parent graph and then do each one of those, and I'm gonna use different colors. And finally, when you finish up, that's what they want. That's for all the transformations. Guys, I'm proud of you. Not too proud of some of those scores I saw. I'll get those quizzes back to you before we leave. But it was the first quiz, so I had to keep that in mind. First quiz, new professor for you, new students for me. Stressed out. I know you'd like to have a life, but I'll share with you a little short story I usually tell, and then we'll take a break here. I forgot to open up my class Monday with this story. If you have, let's say you're home with your parents, or you have a boyfriend, girlfriend, or someone special, I suggest that you sit them down and talk to them. And if you have that boyfriend,